All right. Hello, everyone. We're going to pivot back into where we were with our lesson this morning on the request response cycle and how that kind of like works in conjunction with the internet and the web and HTTP. Cool. So where we left off, I believe we were talking about the response, and we hadn't yet defined that. But the things I want you to know about the response are that the response is built by the server. All right. It contains information that's organized based on the standardized HTTP request. All right. So whatever was sent over as far as like the path and the verb to the verb connected to that path, that is going to dictate how we kind of organize our response. All right. Yeah, the response is also HTTP. All right. So we'll talk a lot about we'll probably talk like a little bit more about the requests in terms of HTTP, but I want you to know that the response is also governed by this protocol. And the response is rendered by the client. All right, so the client is responsible for taking that information and then displaying it in some way. Cool. So I also defined HTTP, or actually I did not. I took this right from one of y'all. Thanks for those of you that responded to the thread. So yeah, it stands for Hypertext Transfer Protocol. And really what it is it's a set of rules so that everyone on both the client and server side understand how we're going to exchange information. And realistically, I want you to think of it as like the language of the web. All right, so it's the language that both our server and our client can understand. Cool. What else? Yeah, so then I've got some answers to these questions here. I kind of like pulled these from, I think I want to say Shonda, yeah, and then kind of broke down a URL that we have up here, and I'll just put that here to make it easier to see. So our URL is this entire thing, right? Oh, I'm going to stop real quick. Garrett, what's up?
Hey, so yeah, I had a question about the response. So taking it out of the context of specifically like a request response loop that is taking place in like the World Wide Web, and maybe taking it to a place like might happen in like an API or something between two pieces of technology that aren't necessarily related to the World Wide Web. In that type of scenario, like, do the two technologies that are interacting with each other have to be programmed in the same language, or is there a way where like one, like the request can be made in like, I don't know, like Ruby, and like the, you know what I mean?
Yeah, totally. And I would say that this even does this will extend out even to the web. But like, yeah, if we take two APIs, right? Like we don't care what these two APIs are written in. They could be written in, totally different language. One's in C, one's in JavaScript. As long as the governing body of how we will send information is the same between both of them, we can abstract away how that information is processed, because at the end of the day we're using the language to process information on both sides, and it doesn't actually matter what we're doing there as long as the way that we send the way that we send the message in between the two is governed and the same. So HTTP is one way for doing that. Cool. All right, so I'm going to get into parts of the URL. So we've got the entire URL, and if we break this down, the protocol here at the beginning of the URL, the next thing we see is the domain. All right, so this is taskmanager.herokuapp.com. All right, so this is kind of like the beef in between any of those forward slashes. Then we have the URI, or the path, and for this example up here, it's task. So the task would be my resource, and then new. We'll say that new is kind of like part of the path in directing us as part of like what to do with this resource. And then we also have a query string in here where we have some parameters. This question mark, this is always going to like indicate that, hey, I'm about to pass you a query string of parameters to like pass in along with this request. So this one, it would be, hey, the title is new, and we'll separate query parameters with this ampersand, and then my task is task. All right, don't worry too much about understanding the inner basics of that. I want you to understand like, hey, this question mark query string, how do I separate different parameters? This ampersand. All right, and then we also have a fragment identifier. Don't worry about too much from this. This is kind of like just in my last PD session, like we went to that page, and when I clicked on the page, it brought, or I clicked on a link, it brought me to a certain section of the page. That's what this like fragment, we call them fragment identifiers or anchors. That's what they'll do. Cool. And then, yeah, so the path is going to be like the specific resource that we want to interact with, right? Like it's going to be, our application probably has a number of resources. I would think of when I say resource, think of object. It's going to have a number of objects that I want to deal with. And this resource, this is going to be part of the path. And that's going to tell me, hey, we're dealing with this type of object and we're going to do some things to it based on what's in the path. Cool. And then, yeah, there's 5 common HTTP verbs. And yeah, they all kind of like do a different thing, and they all kind of like work in conjunction with this idea of CRUD. CRUD is like what we're doing to resources, so we could be creating them, reading them, updating them, and destroying them. And honestly, like a ton of the apps that you see and interact with on a daily basis are simple CRUD apps. So they're hey, we're going to create a new resource. We're going to read a resource and show the user some information. We're going to edit a resource and update it. And oh no, we want to delete this. We want to destroy it. All right. So I think George sent me this. Yeah, thanks George for sending this in. This was solid. So it's here are the 5 common HTTP verbs. I believe that there are like, I know that there are more than that. Sometimes we say like, oh, these are the 5 or the 7 common, and I think there's 11 total. But these are the ones that I want y'all to really focus in on. It's get, so that's like read some information, display some information to the user. Post, create a new resource made from some info that we sent in our request. So this right here, this URL has a couple of things that make me think like, oh, this is probably a post because it's got this new. So that makes me think, oh, I'm creating a new resource. And it's got some parameters that are coming over here that make me think, okay, like these are the things that I'll probably like use to create the new resource. So yep, so we use post requests for those for creating. Put and patch, they are similar, not the same. They both update a resource. Put updates the entire resource. Patch will only update part of the resource, all right? So if I'm changing my username, but not all of my personal address info, then that would be, that would be a patch. If I'm, updating my entire personal info for, a website, then that would be a put. All right. And then delete. Yeah. If I want to like delete something, if I go to, Instagram and I'm like, I don't want this post to be able to be viewed anymore, then I would say this is a delete. This is a destroy. I want to remove this post. It would probably be like the resource would probably be a post, and I want to destroy it. Any questions coming up on these definitions, questions that I've defined here? Hope I got the old up, down. Okay, Will, what's up?
Yeah, this may be too detailed, but I'm curious, why do they have a patch and put versus just one? I'm visualizing this and tell me if I'm wrong, but if it's like a relational database, the put would be, we're updating every field in the record, and patch is updating just one field. So what's the advantage of having 2 update methods, I guess?
Yeah, that's a good question. I think the advantage would be like, we don't want to update the entire resource every time unless we have to, right? Like the amount of information that we're sending, the amount of, columns on our database might be in like the hundreds, might be in the thousands. And if we can limit the number of columns we have to update, then we can limit the processing time, we can limit the time of the request response cycle, we can limit everything, right? Like, and now things are much quicker if I only do a patch instead of a put when I only need to update one specific piece of the information.
Okay, so like with a put request, if you did a put request, but you really wanted to change one field, what it would actually do is send an update to all the fields, and all of them would have the same entry that already exists, except for the one changing field.
Yeah, I would say if you got a put and you only wanted to update one field, then that would be like a flawed program design, right? Like you would have a flawed design there where like, and this certainly happens even in the real world, where it's a put request and it only has one piece of data, but it's a put, and now it's updating the entire resource, and instead of one of the unintended consequences is like, now maybe instead of having the resource that had all of the personal information, now you only have one piece of personal information, and unfortunately the rest got deleted because it was a poor design and you did a put. Yeah.
Yeah, it seems unlikely then that you would ever really do a put. Is that right? You almost always want to do a patch.
You do a patch if you can. You might need to do a put sometimes. Yeah. Cool. All right. So the next thing I wanted to show you, I kind of want to show you two things. So just this picture of the internet real quick. This is what I want y'all to think of when you think of the internet. I want you to think of like physical locations on the map that are like distributed, like that are real machines and that are just stacks of actual servers that have the ability to relay information, right? And like, then I want you to think of these connections here that you can see as these colored in lines as literal cables that are at the bottom of the ocean that are connecting these 2 points. And I want you to think of like, okay, like many people's jobs is to speed up this process and to make sure that these connections are dependable and are functioning as fast as possible. And I want you to think like these are fiber optic cables, and they are connecting the servers all over the world, which eventually end up at your router or my router in our homes. But even with Wi-Fi, right, like we eventually have to go find a resource on a server, and there's no telling where that server is. Most of the servers that we're accessing from the US are in the US because that's just a better design pattern and it takes less time to access them. However, if I, accessed a website that is based in Germany, there's a good chance that I have to like cross this fiber optic cable and go to Germany to get the information from the server. And then I'll get a response that also has to go all the way across the globe. So just want you to keep that in mind. Like when we say the internet, like the internet is like a physical manifestation of like servers and cables. I saw a hand and then it went away. Okay, I'm gonna show you this design now, and I'm gonna kind of like define it and show it to you, and then I really want you to try super hard to recreate it based on like thinking about like maybe referencing the lesson plan, thinking about the parts of this design that can link up to the analogy of a pen pal, and you having a pen pal on the other side of the world, and then thinking about that in terms of the request response cycle. So here's this brilliant design made by none other than Brian Zanti. I think I added one arrow to it, but it kind of like defines like how we would send something using, if we have a pen pal and we're using the postal system as part of our design, then this is how we would translate information with this analogy, right? And so let's define some of these things. So in this analogy, what do we think the client is? I know we've got to have at least one taker. Zach, let's hear it.
That'd be you.
Yeah, I think, yeah, I'm the one that's like writing the request, right? Like I'm the one here that's saying like, hey, I want to write this request, and you know, I think like you could say like, all right, isn't that the user though? And yes, but in this example, I'm the user and the client. All right, so I'm the client. I'm writing the request onto, you know, my letter, and then yeah, I'm sending it out. So in this particular example, what do we think the server is? Yeah, Cheryl, go ahead.
The pen pal?
Yeah, it's the friend, right? They've got to interpret the request and then figure out based on that request what kind of response they're going to send you. Cool. All right. So in the example, what do we think the HTTP request is? This one kind of like gets a little bit muddier, but I'd love to have you take a crack at it. Curtis is up first.
Would it be like the address on the letter?
Yeah, exactly. So I would say it's like the address on the letter, and then I think like a part of it, you could also say a part of the request would be like the postage you need, right? The stamp you could think of as like the header as part of the protocol that you need both, right? You need the address is like the body of information, or really that's like the URL of like where you're going to. But then you also need the stamp, which is like, hey, like you have, you know, you can send this and readily expect that because you're using the stamp, which I would think of as like HTTP, like whatever we've decided, you know, are the rules for sending this, you know, it'll make it to the other side of the world. Cool. How about the response? Hope.
In this case, the response is a little more literal.
It sure is. Anything to add?
Well, it's taking, assumingly the pen pal is actually responding to what you said, and is therefore taking what you sent them and building a response based on that information.
Yeah, absolutely. So I would think of like the I would think of the responses if your friend sends you the letter back, which we hope that it does. If we assume that this is you know, a solid pen pal friendship, then the response is their letter back to you. So if we just think about the protocol and what we know about HTTP, what do we think HTTP is in this analogy? Slightly more difficult. Yeah, James, what's up?
I suppose you would say it's the whole postal system, the plane and the train.
I like it, but I think for this analogy, that actually works better as thinking about that as the internet. Because this is like a system designed for delivery, right? And the internet is similar. Like we have to have like a physical manifestation to like bring the letter back over to the friend. But HTTP is something that kind of like defines how we interact.
So the letter?
You're on the right track.
I think I'll pass. Gotta do
All
a
right.
little.
Of course, you can pass. Yeah, let's hear from. I haven't heard from Joshua. I don't think.
Is it the language the letter is written in?
Yeah, absolutely. That's what I want you to think of as HTTP. It's like the language that allows you to actually have information sent back and forth because you both understand, right? If you didn't, if one was using FTP, the other was HTTP, it wouldn't work, right? Like those aren't going to work as far as protocols. Similarly, if I speak English and someone else speaks German, like generally those two things are not going to work. We're going to have a poor request response cycle. Okay, with that, I'm going to put you in breakout rooms, not necessarily because I think like you should be working together like on this, but I'd like you to recreate the diagram with some labels here. All right, and so these are the things that I want you to label, and I'm going to put those in the chat. And then I'm down for you to create your own diagram too. So I'm down for you to create your own analogy, I should say. Everyone makes a diagram. If you have an analogy that works better for you, use it. If you like the pen pal analogy, use it. Right? That's going to be. I'm good with either way. And then I want you to label these parts that I just put in the chat. All right, and I'm gonna make some breakout groups and then get y'all going. Any questions about what I'm asking you to do? All right, cool. I'm gonna make sure I don't have too many instructors in one place, and indeed I do. All right, move here. And all right, cool. I'm gonna open these rooms. We'll take you don't have to be Picasso. We'll take 6 minutes. Greg, did you get assigned to a room? All right, looks like everyone is back in main session. Okay, I'd love to hear from anyone that thought of a different analogy. Did anyone do that? Awesome. Let's hear from Kate.
Okay, so in all technicality, we came up with one, but had a very hard time with a part of it.
That's fair.
And I started a diagram, but I haven't gotten done with it yet. But when I'm done, I'll share it with the group. The analogy is ordering a pizza. So the way that we got through that was you have the client, which is the hungry customer. The request is the phone call or app order of said pizza. Oh God, hold on. The request, so the actual request being like, you have to know which location you're ordering from. So you have to have like a store number, phone number, or number so you can order from the right location. So you place your order, the response is actually getting the pizza. The server is, of course, the pizza place. The only thing that we had a really hard time with was what is the internet with this, because in all technicality, it's like the ordering system within the app takes care of almost everything except for the delivery of the pizza, which is an outside of the app thing. Though whenever somebody figures out how to make an app that will actually like materialize a pizza in front of you, I'm down for it. But couldn't really come up with that just yet. But that's kind of how we had that.
Yeah, I love this analogy, and I would think of the internet as basically the inner workings of, if you order it from an app, then the internet is probably the app, right? And like how it's like connected to like you don't see the in-store, server, but the app is like your client that it's kind of like a literal analogy in that form. However, like ordering it by phone, now the internet changes to the actual like phone company that is like processing your call, right? Like you hitting dial is like sending the request, and then like talking to the pizza guy is like exchanging via HTTP, and then the internet would be like the phone company in that example. Yeah, so how you order, I think, is like would define that. But I love this. I think that's like a brilliant way to think about it, and I'm definitely hungrier now.
And P.S. This is all Sean's fault. It's 100% Sean's fault. He was just as hungry as you are.
Awesome. But hey, hunger can come in handy, I guess, sometimes. Cool. All right. Thanks for sharing that, Kate. John, what did you come up with?
Honestly, I just wanted to share because I wanted to share my drawing. And I guess I can't screen share, so never mind.
Well, I can't see you because of your virtual background, but I feel like if you turn off the virtual background and hold it up to the camera, then we can see it.
Oh, I made it on the computer.
Oh, you did? Okay, well, you can screen share. I'll stop. Hold on. Let me stop sharing. All right, you should share now.
All right, so I will take autographs later, but anyway, if you want to commission me, just email me. But anyway, so I had Subway for lunch, so this is my Subway analogy. And I know it's not exactly how Subway works, but so here's me, the client, and I put my order into the person at the clerk. I'm sorry I didn't make there we go, equal opportunity. So the clerk is my internet, and they are going to send my order over to the sandwich maker, who is the server. And the language that we use to talk to each other, vocal order, is my HTTP, because believe it or not, if you try to speak to them in Japanese, they don't understand. And the order is my request. And then when the server, who is my sandwich maker, gets the order, he or she makes the sandwich and sends it back to me, and that is my response, and that's my sandwich.
That was a great sandwich response. I appreciate you sharing that, the diagram. Awesome. All right, so I can tell that no one, or well, you did have lunch, but I can tell that some of us are hungry, and that's okay. And yeah, thanks for sharing that, y'all. I want what I want to leave you with is the entire time we're building these web applications, this entire mod and beyond there, you are in some part of this request response cycle at all times. And I think thinking about where you are at all times and like coming back to that will help you understand where you're at and what part of this you're trying to build at any given time. So I want you to like at least keep this stuff in mind, because it doesn't matter what part of the application you're in some part of this cycle. All right. Yeah, George, what's up?
Yeah, you were talking about like the stamp and the address as being the HTTP response or request. Was that right?
Request.
Okay, so like the actual letter itself, like all the words that I'm saying to my pen pal, like what in our words, or like I was trying to go back in our like learning and our vocab, like what exactly is the letter inside the envelope. Could you just expound on that a bit?
Yeah, totally. And I think like the analogy doesn't like necessarily have to be perfect, but like the letter is the request. So I want to like say that like the letter is the request, HTTP is the language, and then I was thinking of like the address and the stamp as like part of the request. So like that's like a part of it, right? Like the address is like the URL, and then the stamp is like part of the protocol that says like, hey, like we can do this. It's part of the HTTP. I would think of it as like probably like a header or something like that. But I was kind of like breaking down HTTP, and I should have just said like, no, like the whole letter is the whole request, and HTTP is the language, and then like parts of that language, I was where it kind of got a little fuzzy, and I broke it down a little bit. Cool. All right. I think I'm going to stop there. Brian, I don't know how you want to proceed.
Let's go ahead and take 5, and we'll go ahead and be in the different Zoom room. So I think some of you all joined it before, but it's in the calendar event under project kickoff and work time. So we're going to close this one out, and then we're going to